Okay, guys, we're going to get started. Thank you and welcome to our 2025 Ways to Inspire, 2026 Ways to Inspire conference. The annual conference we run every year. I'm sure you know all about it. So we're going to get right into it. We've got really exciting stuff to talk about today. The brand new Mark 5 module from it's the first kind of truly fifth generation sort of module that's come out. And what's really unique about this is the completely enclosed design. That's something that we had been doing as kind of a modification on the Mark board for a couple of years, printing a little housing around it to keep the grease in and the debris out. But the Mark 5 is designed like that from the ground up, including the bevel gear on the wheel, which was sometimes prone to picking up debris off the carpet and tape and junk like that. So SDS was kind enough to send us a set of modules to build up at this event. So we're going to get right into it. So here we go with the MK5n. Right off the bat, there's a nice little grease packet that comes with the module, and it's the like red and tacky grease. So that's pretty jam. So this red and tacky grease, it's really great. It's super sticky, and it doesn't pick up like a lot of other greases does. So this is a really nice touch. The main turret gear. So they've gone away from the steering belt. The previous generation FDF modules all had a timing belt that drove the turret. And sometimes you get like a piece of debris or a bolt or something that would end up damaging that belt. And that was one point of failure on the old modules. Completely eliminated with the new design, the gear-driven turret. And just right off the bat, you can see the quality of the machining is really impressive. Like all the little chamfers and everything, like this is significantly better than we can make ourselves. Next thing, and this is what I've been really super excited about, is the new wheel. The new wheel, they've got what's called the spiky grips, or the spiky wheels, and it's a whole bunch of little rubber cleats that interact with the carpet. And before this, everybody pretty much used tread or Holtzman wheels, and they were kind of the gold standard in traction. But the new spiky grip wheels, the traction that they offer on carpet is a step better than pretty much anything else out there. And just when you look at this wheel, like it's 2.25 inches wide. So the old wheels were 1.5 inches with tread. This wheel is like mega wide, so that gives you a little bit better traction and longer tread life. So even though this tread is a little bit more expensive than a piece of conveyor belting that we used to use, it's going to last a whole lot longer. So the actual cost difference is pretty negligible, in the long run, because you're going to replace them, 1/4 as often. So this hub comes apart, and the treaded portion can be replaced when it wears. You stick a new one in. This one's all pressed together, so I'm going to use this one again. The new turret gear has an angular contact bearing, and for the MK5, we've gone with a sealed bearing instead of a shielded bearing. So it's actually got this rubber seal all the way around that's going to keep out dust and debris from the module. So this is a nice little upgrade from all the previous gen modules. There's the new wheel fork with the enclosure for the bevel gear. So it keeps everything completely contained. Yeah. So the MK5 comes with all of the gears you need for all of the different speed ratios available. With the old generation modules, you had to buy a new gear set and then take a whole module swap the gears out inside, and put the whole thing back together again. The pinions on the motors are the only thing that you change. So if you want to swap gear ratios, if you want to change from a slow ratio to a fast ratio, you can do that on the robot in about 5 minutes without disassembling it. The design is really, really simple. So for the purposes of this demo, we're going to build up the R2 ratio. The old ones, they had L1, L2, L3. The new gearing, they have R1, R2, R3. For most teams, R2 or R1 is going to be the right ratio. R3 is very, very fast. So unless it's like a crazy game where you're racing around the field, R2 or R1 is going to be the right choice for most teams. Another pack of gears here. The bevel gear, all one piece. So the shaft, the bevel gear, and the spline, they're all machined out of one piece. So the old drive shaft, the bevel gear was separate. So what that does is it eliminates any backlash between the shaft and the gear because now they're one piece. So less backlash is better for drive accuracy. It's better for pretty much everything. The new double gears, again, one-piece design, 2 bearings on both sides, but there's only one of them. We don't have a different set for L1, L2, L3. It's just one for all of them. New wheel side bevel gear. This is the intermediate gear. And that's one drive. That's our steering pinion. We'll get to that later. Whole pack of bearings. We'll get to those in a bit. The new steering gear assembly. Really slick. Again, one-piece design that has both gears on it. So no backlash. Hardware pack. That in a bit. Spacers. Idler gear. That in a bit. New wheel fork. Again, machining quality on this stuff is just unbelievable. That's the encoder cover. And this is the new housing. So it's a one-piece injection molded design that houses the encoder, a bunch of gears, the motors and everything mount to this. And it's a piece of glass called nylon. So it's very, very robust. And quite lightweight. The other select thing is it's got these brass inserts for a lot of teams like to make cameras on the swerve modules. They can kind of have them pointed out on the diagonals. So I wouldn't put something structural on it, but if you're going to mount like a camera or a sensor, that's a nice little feature there for other stuff. That's the bottom plate. And then the main plate. Main plate and the idler. Really slick unit here. Again, the machining quality is really quite impressive. And a sticker. I'm going to set this aside for now. then we're going to get right into it. So the other really super handy thing is every box has this handy dandy QR code on there. So if I scan that QR code, it takes you to the assembly guide. So you don't have to go searching on YouTube or whatever else. It takes you to the full assembly guide that's really well done. And it's got step-by-step instructions on how to assemble this thing. So we're just going to go through this. And yeah, if you have questions, feel free to stop me. If there's any questions in the chat, feel free to ask them there. So the first thing is to install the mag encoder magnet into the turret assembly. So we're using a CTRE mag encoder. We're big fans of CTRE components. They're performance-wise, in our opinion, the best encoders on the market. And support-wise, if you ever have a problem with anything, their support is phenomenal. So the first step is to put the steering encoder magnet into the turret with some retaining compound. You want to be using like a Loctite 609, or you want to be using a retaining compound, not a thread locker. Regular Loctite, like a 243, is good for bolts. It's not good for holding in a bearing, shaft, or a magnet. So we want to be using a retaining compound like Loctite 609. One thing to note, Loctite 609 has a shelf life of about 2 years. So if you've got a bottle that's been in your toolbox for the last decade, throw it, buy it. It's not inexpensive, so don't buy a big jug expecting to go through it. Buy like a tiny little bottle and don't leave it sitting around too long. Because your steering encoder coming loose is like, you have one wheel now pointed sideways. So it's really important that your steering encoders be glued in. They recommend not using super glue because the super glue working time is short, that you can put the super glue on, stick the magnet in, but not get it all the way down, and then it's not going to plate. So Loctite 609, that's not a decade old. We're going to apply that generously on the bottom and then shove that in there. Give it a little twirl so that the Loctite gets all around. And then I'm just going to wipe off the excess. And this will take about 15 minutes to set up. So we're going to try to not touch that too much for the next few minutes. Next up is the turret bearing. So that's our big angular contact bearing in the main plate. So that goes in here. Oh, that's a nice fit. That goes in there. And then it's retained with 5 1032 by 1/4 inch button head screws. So I'm going to do my 5 1032 by 1/4 inch button head screws. And we want to put them with some blue. Just a dab. Oops. Just a dab. I'm going to grab my 1 inch. Try not to get any Loctite around the seal of the bearing. It's not going to do any damage, but you just generally don't want Loctite in a bearing. And you just need a little dab on the end of your bolt. You don't need very much. There, they're all in. And I'm going to torque those down. get a, I really like T-handles for this, but get a halfway decent Allen wrench that's got a good clean edge on it. It's really easy to grab an old Allen wrench out of your box that's got the end rounded off of it, and then you end up stripping the heads out of the screws in the process. So invest in good quality tools. The STS actually sells this kit. It's got a Bondhouse 532 tier handle and a 25 driver. It's worth the money for these. And definitely get a good 1/8 T handle. Get a whole set of one. I get a whole set of handles, good quality handles. It's worth the investment. So there's our turret bearing. The next thing is to put the bottom plate on with one of the spacers. And this just makes assembly a little bit easier because then you can put the module on its side. I'm going to pull this one apart again later, so I'm not going to put Loctite on this particular bolt. This isn't in the assembly guide, but I made these two little standoffs that just hold the edges up. And we'll just hold this thing together while we're in the process of assembling this thing. One thing that's really slick about this whole kit is the hardware they've selected makes it almost impossible to put the wrong bolt in the wrong place, because it's really, really obvious what bolt goes where, and if it's not the correct bolt, it just won't fit at all. So it really eliminates assembly errors if you've got a group of inexperienced students assembling. So there's the bottom plate. The next thing we're going to do is put the idler gear in the bearing housing. Oh, I missed a step. There's two bearings that go into the housing first. So again, just like the hardware, the bearings, it's almost impossible to, like, it's really obvious this is not the bearing that goes there. It's almost impossible to put the wrong bearing in the wrong place because of how they've selected the sizes of these bearings. So that one goes there. And that one goes there. So this fit is a little bit snug. So you got to kind of work this one back and forth. And then this guy in the middle is also pretty snug. They got the right one. Yeah, see, there's an example where they picked a bearing that, even though I stuck the wrong one in for it, it was definitely not going in there. So a little trick is to take the double gear, put that on there, and just put your weight into it. You hear that snap? And now it's popped down all the way flush. And I'm going to do the same thing with the turret gear on that little bearing on the inside. Oh, there goes my magnet. So remember how I said Loctite has a shelf life of about 2 years? We have had this bottle in for about a decade, and it's not good anymore. So I'm just going to forego the magnet installation until we get the new bottle. Okay, so okay, that's all the way down. Now is the idler gear. So the idler gear is this big ring gear that's got a little counterbore here and a spot for a snap ring. So it takes this big monster. You got to kind of work this thing in there. And then there's a snap ring that goes in behind. It's easy to get it in there a little bit crooked, and then it'll want to stick. So a little trick is you can just take the other bearing you've got and kind of push it on the table. I've managed to get this one in there kind of cockeyed. There it goes. And then this snap ring goes in behind it. The snap ring just kind of compresses and it pops in. If you kind of roll it around with your hand, it's a lot easier. And then that spins nice and freely, and that snap ring is all the way in. Okay, then we're going to stick this on this guy. This guy. So, little tiny bearing goes in this guy. This thing only fits one way. You'll notice this is engraved with 1, 2, 3 that corresponds with whichever gear ratio we're going to use. So I need the 1032 by 3/4 bolts, and I'm going to stick them in here, and the one that corresponds with the ratio, so number 2. And this guy goes in there with a little spacer on it, so I put the spacer on. And this gear doesn't matter which orientation. This gear goes this way, but the hub has to. There's a little flange that retains this down. If you put this in backwards, the gear will just fall off. So I'm going to put that on there, and then tighten my bolts. We do want to be using a little thread locker on this. Yeah. If you can see, there's 3 spots where this other bolt can go, and this one is slightly slotted. So you want to choose the hole that corresponds with the ratio that you're building on. So that's going to be the middle one for us to choose. Yep. No, so glass-filled nylon is non-reactive. That's one of the reasons why I chose glass-filled nylon. So there's no concern there about how Loctite reacts with other plastics. So a little bit of little dab of Loctite, and then we're going to put this in the slot labeled number 2. And that first one I forgot the Loctite, so I'm going to pull that back out again. When we build storage modules on the team, usually we do this basically exactly like we're sitting here, and we'll have 3 kids, and either a senior student or a mentor, building one of them together, and we just go through the steps just like this. And we build all 4 modules at the same time, and we double check each other's work to make sure that we don't forget a Loctite bolt or put a gear in backwards or forget a snap ring or whatever. So we're constantly quality control checking each other's work. And it's kind of fun because you have this group all around the table doing this kind of interesting activity. So there's the intermediate gear in there that spins nice and freely. And what's the next one? Somehow I got this all out of order. Putting the bearing in the main gear. So that looks like that one probably. And then we put this guy into that from the top. Oh, that's nice. Then we're going to build our pinion miter gear. So that this bearing goes on there. And any gear or bearings left that are remotely close to this side. So I can't even mix this up really far. And it's got this little tube ring on it. So you can push it most of the way on just with your fingers. If you can't get it all the way on, you can either push it with a screwdriver or a little pair of needle nose pliers or something. But you do want to see that thing snap all the way on. I like to just pinch it with a pair of those pliers. Here goes into the wheel module. Like so. And then this bolts to the turret. Yes. Hard enough that it seats all the way in the groove. Yeah, there's a very satisfying like thud when it hits the bottom of the groove, and you should definitely feel that. So now the wheel fork, half of it goes on with the 1.5 inch, 1 3/4 socket heads. Again, we're going to use a little bit of thread locker. .532 Allen wrench. And you want to make sure these are snug. Students can often struggle with how tight. They often make small bolts too tight and big bolts. So a couple of years ago, I actually and like set it to what it should be for 132 bolts so that kids could get a feel for how tight is too tight kind of thing. Get 2 torque wrenches off Amazon now. It's kind of a neat little exercise to just see like how tight is too tight, and getting a feel for that takes a little bit of experience assembling stuff. So the next thing is this little idler gear. This little idler gear has a little boss on one side of it that's all pocketed. So even if you try to put it on backwards, you can't. It only goes on the correct orientation. And then again, another little snap ring. These snap rings have a tendency to go flying, so be careful not to lose them. I'm going to give that a little squeeze. Again, you can use a screwdriver or a set of pliers, but if you can listen real carefully, hear the satisfying click. Yeah, that's what you want to hear. And you should see the snap ring concentric with the shaft here all the way around. Okay. Next step is to build our wheel. So I'm just going to put that assembly aside for now. Again, we've got our wicked cool spiky wheel. Here's the hardware pack for the wheel. Oops. First thing that goes on is the big wheel bearing. That's a really nice snug fit. And then we're going to have our bevel gear. On the bevel gear, we do need to align these tapped holes with the clearance holes that are in the wheel. And they're blind holes, so you can't really see it. It's, a little trick would be to just drop one bolt through from the other side. Hold it with an Allen wrench. and then you can kind of eyeball where it goes. And these, again, we do want to be using thread locker, so don't let me forget to take that one out. Again, the wheel is also glass-filled nylon. The hub of the wheel is glass-filled nylon. So no worries about flux contamination. And again, just a little dab on the end is all you need. I find students, when they're starting out with Loctite, just goop the end of the entire bolt and soak the thing, and you don't need that. The inside hub is glass-filled nylon. The tread is EPU. Yes. Just weight, really. It's a weight and cost. In high volumes, you can make something on very cost, and it's a lightweight material that strength to weight is very, very high. I don't know off the top of my head. It's comparable to aluminum. So, yeah, for this application, it's a great material. The billet wheels are also super cool. They're really nice. And depending on what the majority of the driving surface is next year, should determine what your choice for wheels are. And if it is predominantly carpet, that'd be the way to go. Treaded wheels are still good. Don't get me wrong. Like, we use tread for like 2 decades now, and that's not going to go away. But now that this technology is available to teams, it's going to be a high protection material and the longest wearing material. And there's a couple different companies that make spiky wheels now. You can, some teams are in 3D print. Okay. Oh, the next step, we get to get greasy. Then we install the wheel into our fork assembly here. And get off our pack of red and tacky grease. When you open these, there's a little spout on one end of it and a little mark where you can tear it. It kind of gives you a nice little applicator. So don't cut the other end off of it and then leave this end. Tear off this end, and then you can squeeze it out one side. And you almost can't use too much. That being said, we have one packet to do the whole module, so use your best judgment. You want to apply this fairly liberally. And we're going to put this thing on, and we're probably not going to open it up until the end of next. The swerve modules that are available now, you can get 2-3 seasons, sometimes more, if you maintain them well out of a module. If you tear them down, re-grease them, clean them, put them back together again. So they're lasting a long time. And yes, they are expensive. Debating that. But if it's something that your team is going to invest in and use for the next 3 years, it's not as bad as it seems on. So when you're applying grease, there is no easy way to do it that doesn't get you covered. So just embrace it, dig in, and get sexy. So we want to make sure that all these valleys are filled with grease. We've got a good application to play around. So this grease will mesh with the other one. I'm not going to do the one on the bottom of the pinion. And then we're going to drop our wheel in here. I think you can see a bit better that way. So the wheel's got the bearing behind the double gear there. And this is really, it closes the entire wheel bevel gear so that no dirt or dip. So now that we've stuck that in there, you can see the other shaft. Next step is the back bearing in the wheel. I'm going to wipe the grease off. And this bearing is also a little bit snug. You can push it in just with your thumbs, as long as you get straight to begin with. And then we drop our wheel shaft in. What did I do with the wheel shaft? Here it is. The wheel shaft is the same spacer as what goes in here. They're exactly the same. So you can use them interchangeably. You can't put one in the wrong place. And then the other wheel port goes on. Like that. Again with our 1032 by 1.25 inch bolts with a dab of thread locker. I got a little too much on that one, so I'll just twirl it around. These bolts go through here thusly. And I'll kind of hold the turret so that it can't rotate, and I'll tighten this down. And then next we're going to stick the wheel retaining again with the dab of Loctite. Okay, next step is to start to assemble our gear set. This is another little printed thingy I made that just kind of holds up the module while you're in the process. Bearing for the steering gear. Here's our cool steering double gear. Oh, that's nice fit. And then the double gear goes on bearing. There's no way to put this on in the wrong order. That goes on there. It's saucy again. So we want to apply grease to basically all of these. The intermediate gear that's in the housing, it meshes with both the and the double gear. So make sure you use this guy as well. And the turret gear itself. The turret gear is all of the rest of the gear goes steel. So definitely want to make sure that we're greasing the turret gear. So again, there's no non-messy way to do this. So just dive in. Gonna make sure everything's saucy. This grease is it's called Red and Tacky. You can get it on Amazon. You can get it lots of places. It's worthwhile having this stuff around for other stuff too. So if you've got it, don't feel bad about applying it. Quite generous. Another Canadian Tire. And you want to make sure the grease is in the valley of the tooth. It's not doing any like on the side here. You want to have it in the valley, and then it'll kind of work its way around. One of the really soft details about this thing is they made the gear all non-divisible tooth numbers of each other. So when a set of gears goes, you have like a 20 and a 40. The same tooth on the 20 tooth gear meshes with the same tooth on the 40 tooth gear every second time. So when you have two sets of gears that are divisible by each other, they will wear faster than a set of gears that is not divisible by each other. At every revolution, the tooth meshes with a different tooth, and then a different tooth, and a different. So it kind of spreads the wear around the gear. So a lot of little subtle details that you wouldn't even think about were built. And I got to make sure I keep some for, which is down in the housing, so it's a little tricky. But don't be shy. You're going to get messy during this part, and there's not much you can really do about it. A lot of people wear gloves. Grease doesn't really bother me. And by the time we're done this, we should have basically used up this entire package. And then anything that's on the top of the gear, I'm just going to wipe off and kind of smear. Then you can kind of give this a twirl around and see how it meshes. Oh, I got a big gob on top of it. And the nice part about this is because this thing's enclosed, on MK4, the first time you stand up, it's going to just fling grease everywhere. But this thing is all enclosed, so you're on it. So you can be very, very, very generous with the grease that you apply and not get all over your bumpers. Then the next step is to join together. That's cool. When we fasten the housing to the main 51032 by half-inch socket head and the thread locker. .532 Allen wrench. The main plate has little recessed pockets on it that line up with the notches on the injection molded top case. So it makes aligning this thing really easy, and it locates it dimensionally. So just relying on the clearance of the screw head. So that's a really, really nice touch. The next step is to install the encoder. So the encoder, wee little plastic housing, two little screws. You want to orient this so that the cables are aligned with this little channel. This channel cable actually got a little zip tie hook in it so that you can tie wrap the bundle of cable that comes in a encoder down. This uses a number 1 Phillips screw, itty bitty little screws. And these are just kind of thread forming. They just kind of thread into the nylon housing. So don't glue them down too much. They're also very small and fiddly. Next, you install your encoder with the leads already soldered on it. But I'm not better than that. The leads would be coming out here, and I'd be applying a tie wrap weight. And then the top of the housing goes up with a little thread forming screw. Again, it's a tiny little screw, so just snug it up. Then they have a nice little cover that just provides a degree of mechanical protection on top of the encoder. The encoders are not inexpensive, so it's a nice touch that they've put on to provide that extra mechanical protection. Again, these are thread forming screws, so just snug them up. Then the last step is to install our motors. So we are using Kraken X60 and Kraken X44s. X44 is a new motor, came out last year. Smaller form factor, a lot lighter weight, and just a really nice motor. The X60 is larger, more powerful, and kind of the workhorse of FRC nowadays. We basically use exclusively Krakens. The X44 is kind of the go-to motor now, unless you need more power. And the X60 is a great motor. So our pinion shaft just slides on there, and it's a one-piece thing. There's no space tube, there's no washer, there's no little 50 bits. And then there's a 1032 Torx drive that comes with it. Again, we're going to put just a little dab of thread locker on, and here's our T25 Torx drive. So we're going to put this pinion on. And then this pinion has wrench slots on it for a 3/8 open-ended wrench. So I'm going to wrench on there. Snug that up. Okay. Steering motor goes in. Oops. Steering motor goes in here. Yep. To be honest, I don't know, but if I had to guess, I would say Torx is less likely to. 1032 buttonhead's only got a 1/8 drive, and you use an Allen key that's a little bit round from the end, and you're more likely to strip it out. And then you've got a motor, a $200 motor with a pinion on the end, and you can't get off. So, I think they've intentionally done it to make it harder to strip that pinion. And if you wanted to swap that for a button head yourself, and you're going to be careful about it, by all means do it. If budget was no issue, a flanged socket head cap screw would actually be, but they are obscenely expensive. So again, 1032 by half socket heads with little dab thread locker. I got too much on that. And I think you can use a Minion. That's the CTRE motor that has a secret controller. I think that's the only motor that fits in this housing. It is the motor that makes the most logical sense to use. We swapped all of our steering motors to X44 last year in order to save weight, because X44's got more than enough to steer your modules around. But yeah, I think this Minion is the only one that you can use. And the last step is to install the drive motor, which again we're using. We do a really nice job packaging these, but sometimes they're pain to get out. So really important to note that the X60s come with two vents. This is an option that you can add forced cooling to the motor. You can blow compressed air through it. It's not compatible with this gearbox, so we have to take the one and force through it. We're just going to put a piece of electrical tape over that hole to keep the debris out of the water. So just a little piece of electrical tape. I'm going to install the motor. Notice I haven't put the pinion on yet. The pinion goes on last. And then I'll line up those full holes. We're getting tight on time here, but we're pretty well done. These holes are counterbored and they go right in. So like once you stick the bolt in the house, you can't get inside. The bolt is in its own little cavity, which is really nice for assembly. Last year we actually dropped a bolt into one of our swerve gearboxes, and it was rattling around in there for a while before it by the steering belt. So this is a nice feature. And then I'm going to grab my R2 and I'm going to smear whatever grease I can get left after this packet onto this pin. Yes. There's a little R2 that's laser etched right on the gear. You can't. It's really nice. And then that just drops on there. And then I'm going to put my Torx drive 1032 button head in with the thread locker. And at the end of the motor shaft, I'm going to hold it with my 3/8 wooden wrench. And there we have it. Wipe a little bit of excess grease off the edge, and there is our brand new MK5 swerve module. Lots of nice squishy sounds going on when we spin it. Everything spins nice and freely. Everything feels solid. That is a very, very nice piece of equipment. If the game calls for swerve, this is what we're using next year. There we have it, folks. MK5. We're pretty well out of time. If you guys have any questions, we'll have this module on display in the cafeteria at lunchtime. If you have any questions, free to ask. If not, we need to be moving to our next session. So thank you very much. Yes. We are not running. This is super nasty. Just give me one of the bags and I'll throw it in. Eric, are you good? We good over there? They done? It ends at 10? Oh, I thought we ended 4 minutes ago. Oh, okay. Needs some correction. Well, if he had shown up here on time, he'd be okay. Yes. Ooh, a lot. Um, Probably about $1,000. Probably between 1,000 and 1,200. The mag encoder's 100. These are 300 each. And then the module is like 350 or 360. Yeah, you're like 1,200 a corner. The motors and the encoder are separate. That was it. That was the actual sense. No, that's a separate item. There's a few different options that you can get from a couple different companies. CTRE is the best one that's in it. Yeah, it's a few bucks. But with this coming out, I would expect to see 1-2 year wars that our teams are looking to move off of. And there's lots of, if you can replace the gears, you can replace the bearing, replace the module, and performance-wise, there's no difference. The difference here is enclosed housing, spiky wheel, and it makes it easier to clean gear ratios. But it's 3.9 with no motors, so 5.5 with motors. This is